So rules for exponents. Until now, if you wanted to solve something that looked like a squared, whoa. Okay, so now we're going to go over the rules for exponents. Now you've worked with exponents before. 2 squared is the same thing as 2 times 2, for example, which equals 4. But if you wanted to multiply 2 squared times 2 cubed, until now you would have had to first break out the 2 times 2 for the 2 squared, and then 2 times 2 times 2 for the 2 cubed, and then figure out what that was. 2 times 2 times 2 times 2 times 2, or actually at this stage you just write it as 2 to the 5th. But we shouldn't have to expand powers out before we can combine them. Given something like 2 squared times 2 cubed, I should be able just to go right to 2 to the 5th, and in fact I can. So let's look at that rule first. This is called the product of powers rules. And what that means is product, you're going to multiply a power. So remember, a power could be written as 2 squared times another power, 2 cubed. That's the product of 2 powers. Let me erase this. I'm not going to work with actual numbers. I want to work with variables first. Let's say we have a to the m, so that's a power, some number raised to a power. In this case, a would be 2 and m would be 2, times a to the n. In this case, a would be 2 and m would be 3. Notice it's important that before you can combine 2 powers, the base has to be the same. And since both of the bases here are a, I can go ahead and combine these. And the rule that tells me how to do it, not the expansion and the knowledge and the understanding, but the rule says that all I'm going to do is add the 2 powers together. So a to the m plus n. And if we look back here at this example, we can see that that's exactly what I did. This would be 2 to the 2 plus 3, which equals 2 to the 5, and that's exactly what I got. So there are a bunch more rules that we can work with exponents, but in this lesson we're only going to look at one more. So we have the product of powers. There's another rule called the quotient of powers. So just like the product of powers, where you multiply using the product of 2 powers, in this case we're going to divide with 2 powers. So a to the m over a to the n. Again, notice that the base has to be exactly the same. A to the m divided by a to the m, and the rule for this one says to subtract the power of the denominator from the power of the numerator. So let's do some examples and kind of work our way through this. So let's find the product of b to the 10th power times b to the 8th power. Now, our old-fashioned way of doing this, we would have to write b times b times b times b 10 times and then 8 more times. That's crazy. We certainly don't want to do that. Let's use the product of powers rule. This is b to the 10 plus 8. I know you can do 10 plus 8 in your head, but I want you showing your work while you're learning this new concept. So b to the 10th times b to the 8th is b to the 10 plus 8, which is b to the 18th, done. But I want to see all 3 of those steps. So before we go on to the next example, let's have a little mini lesson. So I'm going to put this little thought bubble here for our mini lesson. So you may or may not have been shown this before, but it's super important that you remember this when you're working with exponents or working with powers. If I were to write the power 4n squared, right? This would tell me that I have to multiply 4n times 4n. And then I could regroup it. 4 times 4 is 16. N times n is n squared. All that's perfect. But you have to be super careful, because when you see a power that looks like this, 4n squared, no parentheses, the square only belongs to the thing that's directly attached to it. Now, in this case, the thing that's directly attached is everything inside the parenthesis. And so everything inside the parenthesis has to be multiplied twice. But in this case, there's no parenthesis, and the only thing the square is attached to is the n. So in this case, the answer would be 4n squared. And that is a big deal when you start looking at, let me separate these out. When you start looking at examples that have negatives in them. So suppose I have negative 2 squared and it's inside the parenthesis. Negative 2 squared equals negative 2 times negative 2. 2 negatives multiplied gives you a positive. 2 times 2 equals 4. So negative 2 squared with a parenthesis equals 4. But negative 2 squared without the parenthesis, only the 2 is being squared. The negative 1 that you had to multiply 2 by to get a negative 2 is not being squared. That's an example like this here. So the negative is still negative, and the 2 gets squared. So negative 2 squared is negative 4. You have to be super careful with that. And in our next example, we can see a case where you got to pay attention to what's happening. (5m squared times 6m to the 4th. So again, look at this. The square is only attached to the m, not to the 5. And the 4 is only attached to the m, not to the 6. So the only thing that you're multiplying or squaring and taking the 4th power of are the m's. So in this case, I'm going to have to rewrite this. Well, notice that 5m squared is the same thing as 5 times m squared, then times 6 times m to the 4th. Well, this is the commutative property. Multiplication, it doesn't matter what order you multiply in, so I can rearrange these things all I want. So I'm going to switch these two. And when I do that, I end up with 5 times, now 6 is in front, times m squared times m to the 4th. Now I can handle my integers first. 6 times 5 is 30. And then m squared times m to the 4th is m. And remember, I want you to show your steps. 2 plus 4. And so 30m to the 6th power. Oops, I wrote that wrong. Hang on. Forgot my 0. Super important. 30m to the 6th power. So I used the product rule, but before I could use the product rule, I had to rearrange the problem to get my integers out front by themselves, operate them, and then I could operate my powers. And so pay attention to whether you have parentheses that put factors together. Remember, 4 and n are two different factors. They're two things that are multiplied together. And so the 2, I have to decide, is it on both of the factors? And in this case, it is not. Let's do one now that has a quotient. So we want to find 5 to the 8th power over 5 cubed. Now I'm going to do something I don't want you to do when you do these, but I like to show you that we haven't changed anything really. We're just making it easier. If this were a simple fraction, I would factor completely, right? I would pop the numerator, so 5 times 5 times 5. Had I paid attention, I would have chosen an example with fewer of 5s in it, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, and then over 3 5s. 5, 5, 5. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. Okay, so normally to reduce a fraction, we would write the numerator as product of primes, which we did here, and then write the denominator as a product of primes. And then we would cancel between the numerator and the denominator, and we'd end up with 5 times 5, well, 1, 2, 3, 4, 5 of them, so 5 to the 5th power. Nothing wrong with that, but it's time to put on our big math pants now. We've all grown up, and it's time to use properties instead of expansions. So we want to use our property, and remember the property says subtract the denominator power from the numerator power, and first make sure I have the same base. I do. The base is 5, the power is 8. The base is 5, the power is 3, or the base is 5, the exponent is 8, and the base is 5, the exponent is 3. So I can take my base and take the exponent of the numerator, 8, and subtract the exponent of the denominator, and that equals, whoops, let's put it down here where it lives. That equals 5 times 8 minus 3 is 5. It's exactly the same thing in both cases, but this one, a lot less work and a lot more mathy because I'm using a property. And we like the properties or rules for exponents. So let's do another example, this time again with quotients, only we want to make sure to take into consideration the little mini lesson here. Let's reduce 7c to the 9th over 21c cubed. Okay, so first thing we want to notice is that the 7 over 21, the 7 and 21 are not part of the power, right? This 9 only applies to the c, and this 3 only applies to the c. And so I can use my rules of powers and, of fractions and factors, and I could actually write this as 7 over 21 times c to the 9th over c cubed. Well, reducing 7 over 21, we just finished our unit on products of primes, or finished our section on products of primes and reducing fractions. You can either write this as a product of primes and reduce the 3, or you will notice that there's a 7 in the numerator and a 7 in the denominator. Let's go ahead and write it as a product of primes. The numerator factored is 7. The denominator factored is 3 times 7. Those cancel, and I'm left with a 1/3 times, well, this is now my power, my quotient of powers rule or property, c to the 9 minus 3. So now when I put it all together, I get 1/3 times c to the 9, take away 3 is c to the 6th, and I can write it this way, or sometimes I'd rather write it as c to the 6th divided by 3. Okay, let's do one more big example. I have 5x to the 4th times x to the 6th divided by 10x to the 5th. Okay, so first I have to figure out whether I'm using the power on or the exponent on my number, and I'm not. I don't have any parentheses, so the 4 is only on the x and the 5 is only on the 10, which means that I can separate these out. I can break them apart into 5 divided by 10 times x to the 4th times x to the 6th divided by x to the 5th. Okay, well, let's start with the integers, or the fraction. 5 divided by 10 is the same as 1/2. If you don't want to write it out as a product of primes and cancel, that's fine. And then this has two things going on. It has the multiplied, right? It has a product of exponents, and it has a quotient. We're going to do the product first. So I have x to the 4 plus 6 using my product property, and I still have to divide by 5. So I have 1/2 times x to the 10th over x to the 5th. Or I have to divide it by x to the 5th. I think I misspoke up there. Now, 1/2 times x to the 10 minus 5, which equals 1/2 times x to the 5th power. And I can put it all together as x to the 5th over 2. So notice that there were 1, 2, 3, 4, 5, 6 steps. And I know you guys don't like to write steps out. I know you do everything you can to take a shortcut, but there is no shortcut to getting smart. Getting smart is about working hard. And in these problems, the more time you spend writing every step out, the better you're going to be processing these when it's time for you to be able to work with bigger and bigger problems. So no shortcuts. You have to write the steps out. First, separate the integers from the variables. You can deal with your integers until you're done and then carry it along with you. And then the variables, you have to write the 4 plus 6 step. I know 4 plus 6 in your head is super easy for you. I don't care. You have to write it while you're learning the new process.